So here are some rather similar types of slightly trivial examples. So we have a book, and we know it's about one of two topics: information retrieval, animal health. What is the probability is the book is about information retrieval? So the frequency person, there's only one book. We can't do a set of experiments, so the answer, there is no such question. For the Bayesian person, we will assume the probability is a half, unless we have a different a priori information about this book came from our library, and this library had was by a person studying information retrieval. They probably had more books on information retrieval than animal health, so actually the probability of information retrieval might be higher. But still, there's an answer, which answer can be given dependent on one's a priori knowledge. So Bayesian people have an answer to that question. Frequency people cannot, because there's just one experiment. This is a very important difference between these two types of probability. Frequency people, or frequency interpretation, requires you to be able to do this experiment many times. The problem with that is you can often only do the experiment once. So, in the frequency case, we can actually change that question and make it a frequency question by assuming that that book came from my bookshelf. Then the frequency person would actually give the same answer as the Bayes person, because it would be just the fraction of books on information retrieval in my library. So that points out that by rethinking what you're talking about, you can actually either get no answer or an answer. So if we come back to this book lying on my desk, this just says that even though we knew the book came from the library, the frequency person still has a problem because there is only one experiment. And he can only give you an answer about the random book. So his answer will always be biased or always correspond to the frequency of you taking the book off the shelf. So if you ask a question about, I have a book on the shelf, it's gotten from my library, I keep taking it from my library many times. What's the problem? What are the fraction of times that book is a book about information retrieval? That's a fine question which Bayes and frequency will give you the same answer to. Again, we have the same example of the dice which I've originally given. If you take one roll of a dice, what is the probability that you get a particular number? And the frequency person has a problem because there's only one event. Bayesian person has no problem. He says it's a 6 unless there's some a priori reason to believe the dice is biased. What happens if you actually look at the dice? Then for the Bayesian person, things drastically change. We know that the probability is either 1 or 0 because I know the answer. For the frequency person, he still doesn't have a well-defined question. And because certainty and uncertainty and knowledge has nothing to do with probability. As far as I know, Bayes is universally the right idea. This battle has been lost by the frequency people many years ago, and the Bayes is, for instance, Bayes is the only way we can do physics because we only do each experiment once. So if this comes from March of 2013, belief in Higgs increasing. So that's this probability that the discovery was a Higgs is increasing, even though we've only done the experiment once. So that just so this is a statement about the Higgs, the Bayesian version of probability, not about the frequency of experiments seeing the Higgs body. So given this discussion, we would like to use the Bayesian interpretation of relevance, and we will find probabilities such that they represent our belief that the document is relevant. And we need to express the knowledge and lack of knowledge about a document and its relevance in terms of probability. And we try to find probability functions which are related to other probability functions. They tend to have things like a priori distributions. That Bayesian things tend to always have a priori distributions. In case of books, it's not so obvious what the a priori distribution of books in the library is, because you need to know a little about the person. For dice, you normally assume that all sides are equally likely. That's typically true of dice. So there you tend to know that the a priori probability is 1/6 for every number. So there's usually an important feature that the a priori distribution needs to be thought of, stated, because you can put lots of biases by making the wrong assumption there. And so probability methods are clearly a wonderful way to go. They underlie effectively all these methods can be thought of as in terms of probabilities from the Bayesian point of view. And there's lots of wonderful mathematics, and even though they're not real frequency probabilities, they actually all work well. And there are several assumptions that are needed, and the probability model and the vector space model can be related. You can build probability methods on top of vector spaces, because you can always define vector spaces. What counts is how you define your distances and how you interpret them in terms of probabilities. So that's the end of this talk on this unit on web search, and we will go into more practical issues in the next unit. Thank you.